Okay folks, welcome back. I'm going to be doing a video on the solution for this achievement check question. It's from section 7.3. It reads as follows. Frank's Footlong sells hot dogs at the beach. Analysis of his sales shows that the number of hot dogs sold on a given day follows a normal distribution with a mean of 120 and a standard deviation of 11. So the first part of this question asks if it's reasonable to treat these data as if they formed a continuous distribution. Well, the number of hot dogs, of course, can't be a continuous distribution. It's going to be discrete. You can sell 120 hot dogs, or 121, or 122, or maybe 115, but he can't sell a continuous number of hot dogs. However, it is reasonable to treat them as if they formed a continuous distribution if you can imagine the number of hot dogs that Frank sells varies quite wildly, and so you can sort of smooth those values out since there's so many of them. But we're going to talk a little bit more about approximating discrete distributions with continuous ones in section 7.5. So for now I'm just going to say yes, and I'll ask you to wait till section 7.5 to get more of a sense of whether or not it's reasonable, because that reasonable determination, we actually have a numerical way of determining that. So, part B, what is a reasonable minimum number of hot dogs and buns? You can see this is subjective, but if I go with about 100% as my measure of, reasonable, meaning, there's almost 100% chance for a z-score of positive 3, there would be about 100% chance that he would sell less than that number of hot dogs. So let's just use z equals positive 3. So for a z-score of positive 3, we know that the z-score formula is x minus mu over sigma. And so if I plug in 3 here and 120 here and 11 here, we can basically say that x, with the x value that corresponds to a z-score of 3, is going to be 120 plus 3 times 11. So that's 120 plus 33, 153. So if Frank sells at least 153 hot dogs, then there's basically a 100% chance. Now, the probability that Frank sells, I'll just say the probability that Z is less than 3, we know that's, well, so basically what we're saying is that's approximately the same as the probability that X is less than 153. And if I use this value here and look it up on the table, then we can say that that's about 99.86%. Ostensibly a 100% chance that Frank will sell less than 153 hot dogs. Now, it's arbitrary how close to 100% you want to get before you call it reasonable, but I think 3 standard deviations is pretty good. We capture about 100% of the possible sales. Part C. What's the probability that the stand will sell fewer than 25 hot dogs on a given day? So the question's asking us what the probability is that X is less than 25. So if we work out what the Z value is for 25, we get 25 minus 120 over 11, which is, negative 8.7. So a z-score of negative 8.7, I mean, that's so far off the scale that it doesn't even show up on our table. If you plug that into a computer or a calculator, it'll say 0. The z-score only goes to negative 3. So if I found out the probability that z is less than negative 8.7, the table just laughs at us and says, yeah, that's 0%. Okay, the probability that he would sell that few on a given day is ostensibly 0. Frank's season lasts from May 1st until September 30th. How many days is that? So let's see now. May has 31 days, June has 30, July has 31, August has 31, September has 30. So that adds up to 153 days in his season. It's that same number again. Didn't we just have 153? What a coinkydink. Okay, so on how many days should he expect to sell between 100 and 140 hot dogs? Well, first we're going to find the probability of that. So, so the probability that his x value will be between 100 and 140, well, we need to find the z-scores associated with those two numbers. And so that's the same as the probability that his z-scores will be between negative 1.82. You notice I did 2 decimal places because that's what I can look up on my table, and positive 1.82. So if I look up negative 1.82, actually I'm going to go ahead and split this up into 2 things here. We're going to find the probability that z is less than 1.82, that's the big number, and subtract from that the probability that z is less than negative 1.82, running out of space. And so the first probability, the big one, is 96%. According to the table, it's 0.9656. And I want to subtract from that the probability, the smaller one, which is 0.0344. If I take away 3% from 96%, then basically we get 93%, but it's 0.9312 or 93%. So there's 93% chance that he would sell between 100 and 140 hot dogs, but that's not what the question asks, so we should go back and have a look at it. It says, on how many days should he expect to sell between these many? So 0.93 multiplied by 153 days, and so we get on 142 days he would sell between 100 and 140 hot dogs. Part E, should he expect to sell 200 or more hot dogs on at least one day during the season? Well, right away I can say that we've already kind of figured this out. I mean, there's a 100% chance he would sell less than 153, so no, he shouldn't expect to sell that many on at least one day during the season. But we can basically say that 200, so the z-score for 200 is, what is it, 80 over 11. Oh my god, that's like 7.27. It's a z-score of 7.27. So there would be a 100% chance that he would sell less than 200 hot dogs on any given day. And it's really, really close to 100%. We could, with technology, maybe calculate that, but I think it's going to come out to 99.9999999 right off the screen. So I'm not even going to entertain the notion. I'm just going to say the probability that x is less than 200 is the probability that z is less than 7.27, which is 100%. Therefore, Frank will not sell 200 hot dogs on at least one day. Now, famous last words. This is assuming that all of those days are equivalent. The model breaks down if suddenly Frank hires an extra truck or goes to a festival where there are 20 times more people than normal, and then you throw all of this modeling out the window. But it did say at the very beginning that analysis of his sales shows that the number of hot dogs follows a normal distribution. Assuming that normal distribution, then no. Frank will never sell 200 hot dogs on any day. It's just far, far, far too unlikely based on the normal distribution. Anyway, I hope that helps. If you have any further questions, you know you can always approach me in class or after school or at lunch. Thanks. Talk to you later.